Hi everyone, this is Teacher John and welcome sa atuang YouTube channel. So today, what we're gonna do is to review this class of ours, functions. So we discussed this, pero kung nakuwangan mo, then this would be the right time or the right place na inyong gianhian. So this lesson 1, function as models, we're gonna talk about this lesson outline here. So, meron tayong lesson outline dyan. So, we're gonna review the relations of functions up until the piecewise function. And we have learning outcomes, and I also mentioned this to you guys in our class. So, what we gonna wait? What are we waiting for rather? So, all right. So, let's start this review. Okay. So, what we need to learn first is to understand what is relations and what is functions. Okay, if you are in my class, then you already know. So what are the difference on those one? Because I explained it to you in different passion, right? So all right, for relation, guys, it is a rule that relates values from a set of values called the domain to a second set of values called the range. Again, that is the first set and the second set. So the first set, we call that one domain, or that would be the X. And the second set, that would be your Y or your range. Now, if we continue to read this one, the elements of the domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more outputs. Take note on that certain line, one or more outputs. Okay, so if we say domain, guys, that would be your X, and that would be your input. Now, a relation is also a set of ordered pairs X and Y. Now, on the other hand, we have functions. Now, a function is a relation. So, meaning every function is a relation. Again, every function is a relation. Now, let me continue. A function is a relation where each element in the domain is related to only one value in the range by some rule. So, take note on that certain line, only one. Okay, the underlined words. So if a relation is one or more, for function, it's only one value only. So if you have one X, it should be connected to only one range or Y. Okay, so that would be, so in that case, that would be a function. And in the other hand, if it is not, if dili ganyan na, then that would become a relation. All right, so let me continue. The elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. Again and again and again. If we say function, it should only it should be only one output for every domain or every input. Now, a function is a set of ordered pairs x and y such that no two ordered pairs have the same x value but different y values. So in a simple manner or in a simple language, so if we say function, guys, um, if you have one input, it should have one or unique output. Now, if you have one input, then if there are two outputs coming from that certain input, then that is not a function, hence it is a relation. Okay, now let's continue here. Now, if we try to think a certain machine, so we are putting something in the machine and that would be your input, and then the outcome of what you've done and that machine, and that would be your output. Let's try to check these machine, which of which uh, are are functions or is not or are not function. So for machine A, we have input any letter from the alphabet. The output If vowel, then that would become 5. If constant, that would be 9. So since the input here is how many letters in alphabet? That would be 26, 27, 28. Oh, how many letter of alphabet? 26 or 28? 26. So, all right, 26 from A to Z. Okay. If we say vowel, guys, A, E, O, U, then if you're going to put A, then the output would be 5. So there is no other output. It's only 5. If you put E, your output would be 5. So there are no other, or there is no other output aside from 5. So meaning in every input there is only one output. Then that makes that machine A um, becomes function. So next we have machine B. So in machine B, our input is any whole number from 1 to 10. Also 1 to 3 up to 10. Now the output here is that the input number multiplied by 0.74. So meaning if you put 1, then you multiply that 1 to 0.74, then that would be your output. So there is no other answer aside from that number. If you put number 2, and of course you're going to multiply that 1 into 0.74, and you don't have any other answer. Then therefore this machine B is a function. Okay, because there is no other answer or output after you put your input. Okay, after you put your input in the machine. Okay, so A is function, B is function. So let's proceed in machine C. Now the input here is any letter from the alphabet or any number from 1 to 26. And output here, if A to Y, then the answer is the next letter of that. Now if Z, then your answer would be A. If number, the letter corresponding to that number, that will be your output. So let's start with the letter first. Let me say I put A. So the input is A. Then the output of that is B. And there is no other answer. So the answer will always be B. Now, if I'm gonna put a number, let's just say number 2. So number 2 input is different from letter A input. Again, numbers, letters are different. They're not the same, right? So if I'm gonna put number 2, your output of that is letter B, because that is the letter corresponding to that number. So meaning the number 2 is connected to letter B, right? And letter A in input side, the output of that is letter B. So A is connected to the B output. Again, A input is connected to B output, and number 2 input is connected to B output. So even if the two inputs connected to only one output, as long as your input is only connecting to one output, then still that would be a function. Again, machine C is still a function. This is what we call one to many, a many to one function rather. Okay, now let's proceed on machine D. So machine D is, the input is a two-dimensional image. The output is the image rotated 15-degree clockwise. Anything that you have that a two-dimensional image, let's just say picture frame, or no, any picture rather, that it is a two-dimensional image, and just rotate it in 15-degree clockwise. I think any image you put there has a unique output, since it's you put a unique input. All right, so let me say if you have 2x2 ID or 2x2 picture, you input that one, then the output would be it rotated 50-degree clockwise. So meaning you have, in every input you have unique output to that one. Then therefore machine D is a function. Now, let's proceed to input E. I mean machine E. Um, our input here is any real number. Let's just say 1, 2, 3, right? So output either the number itself or its negative. So if we're gonna try to imagine, okay, we have here, let me try to check it here. So any real number, let's just say 1, just 1, 2, and 3, right? And it's what's stated here for the output is that either the number itself or its negative. So meaning, um, this would be the input, this would be the x. Okay, I'm gonna put the x in the bottom one, bottom. But definitely it should be, for technicalities, it should be on the top. Anyway, if the input is 1, the output would be the number itself and the negative of that certain number. I'm gonna put 2, so the number itself and the negative of that one. Now if I'm gonna put 3, then that would be number itself and the negative of that one. Okay. Let me erase this x to cancel some confusion, or to erase some confusion. Now let me target. So this one, input, it goes here, output, and it goes here, output. Here and here. 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 So as we can see, 1 as input, it is connected on 2 outputs. So that makes our machine, this certain machine, is this machine E. This machine E would be not function. Okay? So this machine E is not a function. Now if we proceed on machine F, any non-zero rational number, as long it's not non-zero, the reciprocal of that number. So let me say, if I gonna put 2, okay? Now the output of that certain number, the reciprocal of 2 is 1 over 2, right? So meaning everything that you put, there is only a unique output. So meaning machine F is a function. Again, machine B, C, D, and F are functions. Only letter E is not a function. Now, let's proceed on the next example here, or should I say functions and relations as a table of values. Now, for the following illustration of functions and relations, we draw from the definition for relations and functions given at the start of the chapter. So give the following examples to illustrate these concepts. So here we have an example here. Which of the following relations are function? So we have 3 examples. So we have set element F, or I mean, sorry, that's set F, or just simply say F is equal to the ordered pair 1 and 2, 2 and 2, 3 and 5, 4 and 5, up until here. So what we're gonna do here is to try to watch, or to look, or to see which of which is a relations and which of which is a functions. So F, G, and H, of course, they all of them are relations. But let's try to look for function. For F, we got x1. So these are the x's: 1, 2, 4, and 3. Okay? So 1, 2, 3, and 4 are your domain input or your x. As you can see, hindi na siya, wala nagbalik-balik. Okay? So because kay wala siya nagbalik-balik, then this example is a function. Next, in letter B, so G is equal to 1 and 3, 4 and 5, 1 and 4, 2 and 5, 2 and 6, 3 and 7. take note, see, we have 2 here and 2 here. We also have 1 here and 1 here. So, yun lang yung babasihan natin. Si X lang talaga. Try to check sa X kung bumalik ba siya. Kasi, dalawang yung target niya. Ito, 1. Unang target niya, 3. Sa pangalawa, ang pangalawang target ng 1 ay 4. So, dalawa yung target niya. So, that makes this example not a function, but only relation. Okay? This letter B is not a function. Now next, we have 1 and 3, 2 and 6, 3 and 9. And we have ellipses here, then so on and so forth, n and 3n. So any number, then that certain number, you multiply it by 3. So meaning, unique yung x natin. 1, 2, 3, 4, 5, 6, 7, up until how many kung gusto mo. Kasi naka-variable na n siya. So, this example number 3 or letter C rather is a function. So, only letter B is not a function. Okay? So, let's proceed to the next one. Here, example number 2. Which of the following mapping diagrams represent function? Here in the first one, ito yung X, yung domain or input. Yan, 1, 2, 3, 4, 5. And this would be Y, your range or your output. So in every X, isa lang yung target. So there's only one target of that particular domain. So therefore, this F or this illustration here or diagram rather is a function. Now here, 5 is connected to 1, 6 is connected to 0, 7 is connected to 1, 8 is connected to 0, 9 is connected to 0. Take note, every input here is only connected to 1. Even though in this side, marami yung nakakonect sa kanila. It doesn't matter. This is what we call many to 1. Okay? This is still a function. Again, this is still a function. Now, how about this? So, X or the domain, we got 7, 2, and 1. 7 is connected to 2y. 2 is connected to 2y. So, therefore, since yung X natin na 7 at saka 2 is dalawa yung kinonect nila, meaning this is not function. Okay? So, this H here, this mapping here or diagram is not a function. Now let's proceed to function as graph in a Cartesian plane. Now recall from grade 8 that a relation between two sets of numbers can be illustrated by a graph in a Cartesian plane, of course. Now, and that a function passes a vertical line test. Now this is the vertical line test here. A graph represent a function if and only if. So, wala na talagang iba. Siya lang talaga. Each vertical line intersect the graph at most, excuse me, at most once. If a vertical line X equal A intersect the graph twice, say at A and B and A and C, then the graph cannot represent a function because two different Y values correspond to X is equal to A. Again, if we're gonna say function in a graphing, dapat lang talaga pag gumawa tayo ng vertical line test, isa lang yung ma-intersect niya or yung masagasaan niya. Okay? Pag dalawa na or mas marami pa, then that would not be a function or that graph is not a function. Now we have example number 3 here. Which of the following graphs can be graphs of function? This A, kahit saang vertical, yung vertical is yung pataas at saka pababa, hindi yung yung paganyan. So vertical line test ganito, pataas or pababa, ganyan. So in every vertical line here, yung graph natin is isa lang yung ito yung intersection, isa lang talaga. Kahit saan mo tingnan. So therefore this A is a function. Now, next illustration here, ito linear kasi line yan. So if you can see in every vertical line here, it intersect to only one. Therefore, this letter B is a function. Now, let's proceed in letter C here. If we can see, we have this kind of graph. Okay? So, in every vertical here, yan, ito, maraming vertical yan. Isa lang yung intersection. So, meaning this letter C is still a function. Now, try to look at the letter D here, or D illustration. So, here in this vertical, nag-meet siya ng dalawang beses. Here as well, 2. So, as you can see, in vertical line test, it intersect 2 times. Then, this graph is not a function. And like this one as well, here, look at this. This is not a function because if we try to look in the vertical line test, it intersect 2 times to that certain graph. So this letter E illustration or graph is not a function. All right, so let's proceed to the next example. Example number 4. Which of the following represent? Okay, which of the following represent a function? So we have A up to E here. Y is equal to 2x plus 1. Letter B is y is equal to x squared minus 2x plus 2. And the last one, the letter C, x squared plus y squared is equal to 1. D is the square root of x plus 1. Next is y is equal to 2x plus 1 all over x minus 1. F, may F pa pala dito. Y is equal to, ano ba to? Greatest integer function. X greatest, x is the greatest integer function plus 1. So solution, all are relation. All are function except C. This one, C. Because that x squared and y squared, pag nag-squared yung x mo, tsaka nag-squared din yung y mo, so meaning this would be a circle or a parabola. Okay? So if the x is squared and y squared, parang circle or parabola yan. So hindi ko na lang isosolve to. As long as if your x becomes squared and your y becomes squared, then this would not be a function. Because if you try to graph, this would become a circle, a possible circle, or a parabola. I'm not really sure. But what I'm sure about this, this is a closed figure. So naka-enclosed ito. It could be a circle or it could be a parabola or an oblong. So if you try to look at the other example here, the y is not squared. Here the y is not squared, the y is not squared. So only letter C, the y is being squared. So therefore, this x squared plus y squared will not it's not following the what we call vertical line test. Then this makes this equation becomes not function. So if we try to continue, C is not a function because we can find an x value that corresponds to more than one value. Example, if x is 0, then y can be plus 1 or negative 1. Yes, that's true. So the definition, the domain of a relation is a set of all possible values that the variable x can take. So let's proceed to the example number 5. Identify the domain for each relation above using set builder notation. So if you can remember the what we call set builder notation. So the solution would be, this would become real numbers. Okay? If we try to put x as 1, so what would be the value of y? So this would be the thing. Okay? So letter B, same, it's a real numbers. Okay? So if you're going to put 1 for the x, then the next table of function, if we put x as 2, so this would be the thing on that particular example, or in this particular example. Then letter C would be your x become -1 and your 1 would become, I mean your y would become 1. So this letter C. Now for D, that would become -1 and positive infinity. The letter E would become negative infinity, or negative infinity and 1, union by 1 and positive infinity. For the last letter, for example, this one, okay, that would be real numbers. So if a relation is a function, then y can be replaced with f of x or a function of x to denote that the value of y depends on the value of x. Do this for the function in the examples above, replacing f with other letters to distinguish the function from each other. Now, for example, here, this one, we change the y into f of x. So here it becomes f of x is equal to 2x plus 1. The next one, 2 of x equal to x squared minus 2x plus 2, so on and so forth. So this would, we're going to read this one as x is the greatest integer function. So this one, okay? So alright, so let's proceed to the lesson proper. So hindi pa yung lesson proper pa pala. So anyway, function as representation to real life situation. A function can often be used to model real situation. Identifying an appropriate functional model will lead to a better understanding of various phenomena. So we have example number 6 here. Give a function c that can represent the cost of buying X meals, meaning X meals, you don't know what kind of meals is that, and you don't know how many meals is that. And if one meal rather, sorry, if one meal cost 40 pesos. So meaning each meal cost 40 pesos, but the X meals, you don't know how many, right? So the solution would become like this. Since each meal cost 40 pesos here, right? So then the cost function is C of x is equal to 40x. Since the x is the number of how many meals, okay? And you don't know it yet. So that's why you put the variable x meals. Then the 40 here represent your cost of your cost in every meal. So that's why this would be your solution. Now let's proceed to example number 7. Now 100 meters of fencing is available to enclose a rectangular area next to a river. So if you can see this figure, this would be like this. The river would be on the top. Okay. Now give a function a. This would be the question. So give a function a that can represent the area that can be enclosed in terms of x. Now the question here will ask us about the area. And as we all know, the formula of the area is length times width. Now, if we can see on this illustration here, y represent as our length and x represent as our width, or vice versa. Whether you can also put this one as your length and this would become your width. But anyway, it doesn't matter because we're going to use length times height. So it's multiplication there. It will not change the answer. So again, for now, let's have a consensus that the y would be our length and the x would be our width. All right. So this would be our solution. So the area of the rectangle enclosure is A is equal to x and y. So this would be the length. No. This would be the length times width. All right. So again, as what I mentioned earlier, it doesn't matter if the x would be your length and the y gonna be your width. It doesn't matter. Now we will write this as a function of x. So meaning we will change this will become an a of x. So since only 100 since 100 meters of fencing is only available or available only, then x plus 2y is equal to 100. Take note this formula, x plus 2y is equal to 100. That is a formula of a perimeter. Now, the perimeter should be 2x plus 2y. Now, why it becomes only x plus 2y? Because as you can see here in the illustration, we're not going to put a fence here in the riverside, because what are your task is just to enclose this area, and this in the riverside, it's not really, you're not going to put any fence here. So that's why it's only 1x and there are 2y. Okay, because this is perimeter. Okay, now we're going to use this one. We're going to use the perimeter formula in order for us to find the what we call this y value here. So x plus 2y is equal to 100. Now if we try to put the x on the other side and divide both sides by 2y, then it will become like this. Okay, that will become y is equal to 100 minus x all over positive 2, all over 2. Then that would become 50, or let me say y is equal to 50 minus 0.5x, because 100 divided 2, that will become 50, and negative x will become 0.5x. Now if we try to put this value of y, okay, this one, the value of y, in the original problem, which is asking us about the function, or the area of the function x, or a of x, that would become L, I mean length times width, or x times L. See? So that would become, in every x, you're going to multiply that one into 50 minus 0.5x. And that, in this particular example, you're going to distribute this x. So that would become 50x minus 0.5 x squared. And that would be your final answer. Because the question here is, give a function a that can represent the area. So meaning it asks us about the area here that can be enclosed in terms of x. So we are creating a function, an a of x. Then as we know that a function, that would be the value of y. That's why we try to find the y first, and then we put a of x is equal to x times y. So that would be your y. And your final answer would be 50x minus 0.5x squared. Now let's proceed to what we call piecewise function. So piecewise function, some situation can only be described by more than one formula, depending on the value of the independent variable. Example number 8. A user is charged 300 pesos monthly for a particular mobile plan or mobile plan, which includes 100 free text messages. Again, that's 300 monthly for a particular mobile plan, which includes 100 free text messages. Messages in excess of 100 are charged 1 pesos each. So if you texted 101, then your charge would become 300 plus 1, because in every excess, um that would be a 1 peso cost. So represent the amount of consumer pays each month as the function of the number of the message M sent in a month. So solution, let T of M represent the amount paid by the consumer each month. It can be expressed by the piecewise function like this, T of M. So that would be the amount paid of the consumer. So if 300, your monthly would be 300, right? So if M, the number of message sent would in between or would be in between by 0 or equal 0 up to 100. So lesser or equal to 100 but not more than 100, then uh your amount or the amount to be paid would be 300. Now if m is greater than 100, then 300 plus the m. Okay, again, let me say 100, your m would be 105. Okay, so you have the excess of 5, right? So this would become 300 plus, basically this formula or this equation is kind of that there is technical error here. It should be m minus 100. So dapat na naka-enclose na rin. Because let's just say you if your message sent is 105, then the excess is only 5. So this would become 105 minus 100. So that would be 5. So 300 pesos plus 5. So there is a technical error here in this side, I think. So you can put enclose or open parenthesis m minus 100 here in this area. Okay? So if m is 105, then this would become 105 minus 100. So that would be 5 plus 300. Okay? Now next, we have example number 9 rather, for piecewise. A jeepney ride cost 8 pesos for the first 4 kilometers. So meaning every whenever you go, as long as it's first per 4 kilometers, so the cost is 8 pesos. Now each additional integer kilometer, if we say integer kilometer, it should be full number, all right, adds 1.50 to the fare. Meaning if you have 5 kilometers, then it exceeds by 1 kilometer, then each kilometer you add 150, so the cost would become 950. Now use a piecewise function to represent the jeepney fare in terms of the distance d in kilometers. Now your solution would be like this one. The input value is the distance and the output is the cost of the jeepney fare. If f of d represent the fare as a function of distance, then the function can be represented as follows. Now f of d, so fare of the distance, the cost of the fare in terms of distance. Now for 8 pesos fare, the distance should be in between by 0 and lesser than or equal to 4 only. Now if d is greater than to 4, let's just say 5, then you're gonna add 1.5 then times the d, or yes, multiply the d. For example, your d would be 5 as what I mentioned, then this would become the excess is 1, so 1.5 times 1, then that would be 1.5 still, then you add 8, then that would be 9.5. Now for example, if your distance is 6, then the excess would be 2, then this d would become 2, then you multiplied it by 1.5, so that would become 3, right? So 2 times 1.53 plus 9, then that would become 11. So the symbol, this one, denotes the greatest integer or floor function applied to d. So the floor function gives the largest integers less than or equal to, let's just say 4.1 is equal to 4.9, and that would be equal to 4. From 4.1 up to 4.9, it will always equal to 4. Meaning, let's just say, since it's stated here that it should be represent each additional integer kilometer, that's why we're going to use this floor function. Okay, this floor function here. So kahit Ano yan? Kaya let's just say 2.9, 2 pa rin yan. So it should be a whole number. Okay? So example number 10. Water can exist in three states: solid, ice, liquid, water, and gaseous water vapor. It takes a certain amount. Water can exist in three states: solid, ice, liquid, water, and gaseous water vapor. It takes a certain amount of heat before water can change state. Use the following information to sketch the graph of the function representing the temperature of water as a function of the amount of total heat added in J. Explain why this is a piecewise function. Now here, first one, a solid block of ice is at negative 25 degrees Celsius, and heat is added until it completely turns into water vapor. Then the temperature of the ice increases steadily and reaches 0 degree after 490 joule. I don't really get it because it's science, but let's try. So the temperature stays constant at 0 degrees Celsius until the ice melts, which happens once a total of 6,950 joules of heat is applied. Anyway, this would become like this, the solution. Kind of not really sure on this one because it talks about science. I don't know about the joules. So let Tx represent the temperature of the water in degrees Celsius as a function of cumulative or total heat added in joules. So how about this? Just neglect this last example. I don't like to answer this one because I can't relate. I can't relate about this one. Just be honest on this. Okay, just neglect this example number 10 though. I am not putting this one into your um in your module. So students, so that would be your class um for your lesson one. It's kind of it's kind of tiring, but it's okay. Again, this is Teacher John, and see you next week. Bye bye.